Alright, we're going to pick up where we left off. This is step 6 of the cheat engine tutorial, pointers. So we have a value here of 100. Let's say it's our health address. And then there's going to be a pointer to it. And the address of the variable is going to change, but the pointer is always going to point to the correct address. So in order to have this always work, we want to use the pointer to freeze the value or change it rather than using the address itself. And so let's start off. Let's scan for our 4-byte integer health variable. Change it to 28. There it is. And we want to right click it and find out what writes to this address. Click yes, you do want to attach debugger and change the value, and then we have move EAX into EDX. And typically we're looking for like an offset here, but there isn't one. And the reason is because it's a one-level pointer. There is no offset. The address just points to the address. So this is really easy. So we have an address, and we want to find the pointer to it. And all a pointer is a variable that the value of that variable is another address. So a pointer contains an address of another variable, so the pointer just points to another variable is all it does. And so to do that, let's take the address and let's do a new scan and let's search for in hex because we're looking for a variable that points to this address. And do first scan, and we already got it, and it's green. Now the green means static, meaning that it's going to be either relative to the base address of a module, or it's going to be the same address in the process every time. So let's grab that address, and we see there is a module address here, and then a relative offset. So hold up, let's grab the whole thing, add address manually, pointer, placed it in there with an offset of 0, meaning it's a one-level pointer, and we see the 727. So this is the variable, this is a pointer, and then this is pointer to health, let's say it is. And so when we click change pointer, now the new value is 444. So now the original address is invalid, but our pointer still points to the correct thing. And if you just keep an eye here on the address, each time we click change pointer, that's going to change. And so just to illustrate what that is if you were coding, so first we have an integer called health, and we initialize it to 1337. We have an int pointer called myHealth, and we're going to set it to point at the address of health. That's the address of operator in C++. And then imagine each time we're hitting change pointer, imagine it's doing something like this, where myHealth is now going to point at a new integer dynamic variable. And so the health variable gets dynamically allocated, and the pointer then points to the new dynamic address. And so that's exactly what this is doing here when you click change pointer. Now, we can freeze this. It should still work, and I think he wants us to set it to 5,000. Yep, and then freeze it. So if we click change pointer again, it should still work. And it did. So now we can click next, and we get to step 7. So for step 7, this is code injection. Basically what we're going to do is we're going to delete an instruction by knopping it. And so first we want to find our health address. It's 100, hit me, 99, and there we have it. So hit me again, 98, so that is the correct address. So we want to find out what writes to that address. So we're going to right click, what writes to this address, and hit me again. And so here we have the instruction that's going to subtract 1 from the value. So let's click show disassembler. And what we want to do is we want to make an autoassembler script for this. And so to do that, we're going to press Control A, and that's going to open up the auto-assemble window. We're going to select the code injection template. Click OK. That's just the default location of the jump. We had selected the right address, so that's fine. And basically what we want to do is, this is the original code. And then we have the new mem, which is where we're going to do our code injection. So let's copy the original code, but instead of subbing 1, we're going to add 2. And then let's click execute. Are you sure? Yes. And so now when we click hit me, it should increase it. It's actually increasing by 2 and then subbing by 1. So what we want to do is we just want to remove original code, comment it out so that it never gets executed. And so now when we hit me, it's going to increase by 2. Done deal. Next, multi-level pointers. Everyone has trouble with, so I'm going to do my best to explain it to you. Alright, so as usual, we want to find our value, 1972. And change it again, 1795. Alright, so that's the address. So that's the value address. So Darkbyte tells us it's a level 4 pointer, and basically what you have to do is you have to use find out what accesses, and you have to trace back each level of the pointer, and each level of the pointer is going to have an offset. So on a 4-level pointer, you're going to have 4 offsets, and eventually you're going to get to a static green address, and then remember that is either relative to the base address of a module, or it's just static across the entire process itself. So in order to illustrate this, I put something together that makes this really easy. And just to explain, when you see this points to, you're going to read it as points to. So we have our value, which is 1795. That's our value, and it's at an address. So we're going to grab the address, copy and paste it. And when we trace backwards, that address is going to be this address. And it'll be helpful I'll explain it from the beginning. So imagine you click add address manually and click pointer and add 4 offsets. That's what it looks like. This is a very good visual representation of what a multi-level pointer looks like. And basically I'm creating the same thing for you in the notepad here. And so basically we're going to trace backwards until we get to static base. And just to show you this forward, you have a static base address that points to an address. You add offset 1, and then you get the end address of that pointer level. And this final address becomes the base pointer for the next level. And then that base pointer points to another address. We add an offset, and it gets to an address. And then that address becomes our base pointer. We find out what that address points to. Another address, we add the 3rd offset, and we get an address. That address gets pasted here. It points to another address. We add offset 4, and then it points to our final variable address. So we're going to trace backwards, and it's going to be really easy. All right, so let's search for 1385. Change value, 1443. We got it. So this is our value, 1443. And its address is right there. We're going to copy and paste that in. So there's our address, and we want to find the offset now. We're tracing just backwards. So offset 4, find out what accesses this address. Click change value. We get ESI plus 18. So the offset is 0x18. And then this address minus 18 equals this address. We're going to copy and paste that in. And then we want to find out the base pointer that points to this address. So in order to do that, new scan, hexadecimal, first scan, and we get our base pointer, which is this address here. And we know that the base pointer of this level is actually the end result of the last pointer. So now we want to find out what accesses that address so we can get the next offset. So find out what accesses this address. change value, and we get move ESI into ESI. And so this is weird. So we don't see an offset number here. So in that case, the offset is actually, there is no offset. It's just like a, think of it as like a single level pointer. So this number minus 0 equals this number. And then so we now want to find what pointer points to this address. So we're going to do a hex scan for that, copy and paste. And we get this address. So that's our base pointer for that level. Copy and paste it again. And we know that this and this are the same, so we'll paste that in. And now we want to find out what offset is used to reach this address. So we'll click right click this, find out what accesses this address, change value. We want to close this stupid window. And we get ESI plus 14. So we know the offset is 0x14. And so this minus 14 equals this number. So we're going to copy and paste it. So we want to find out what points to this. So we're going to do a hexadecimal scan for that. For scan, we get 2 addresses. Let's say it's the first one. So let's copy it and paste it here, and then paste it here. And so we want to find out the offset for that. Offset 1, so we're going to do find out what accesses and change the value. And we got ESI plus 0C. So the last offset is 0xC, actually the first offset, because we're tracing backwards. And so if we take this and subtract 0xC, we get this number, and that's our address. So we want to find the static base address that points to that address. So do another new scan. First scan, and now we get a green static address. So let's grab that, copy it, and paste it in here. What you'll notice here is that this uses, when you see this, it means address of the base address of that module, and then adding a relative offset. So this is static to the base address of a module, which is dynamically located at runtime. So when you go into C++, you need to calculate that at runtime as well. So remember, we had 2 different addresses. It just so happened the first one was the correct one. If we did the second one and we did change value, we maybe would have had nothing here, and that pointer had nothing to do with the instructions that we were actually looking at. All right, let's see if that works. Let's add an address manually to our table. Let's paste in this as the base address. We're going to have 4 offsets here. We have 0xC, 0x14, a 0, and then a 0x18. And let's call it pointer to health. And we see that it points to 973. Awesome. So let's set that to 5000. Let's freeze it, and then click change pointer. And next, it worked. Awesome. So this little text I use here is really helpful, and I think if you follow that method, you will not have any problems at all. Alright, so step 9, shared code. Basically, you have Dave and Eric on one team, Hal and Kit on a second team, and there is one function that decreases the health regardless of what team you're on, or if you're a local player, or if you're a bot. And so we're trying to do an infinite health script, which would be easy if we just knopped the decrement health instruction, but that also gives the enemies infinite health. So the idea here is create a code injection that compares the team and then only does unlimited health if you are on the same team as player 1 and 2. Alright, so health is float value, so let's search for 100, and bounce to attack and attack. We have 95, 96. Oops. So we want to add 95, add 96, and then we're going to search for the enemy team, which starts at 500, and attack, 499, 499. So we have player 1, player 2, player 3, and player 4. So we're going to open memory view, go to tools, dissect data structures. We are going to, well, first thing what we want to do, we want to find the base address of the structure. In order to do that, we're going to right click it and do find out what writes to this address. And we're going to click attack. And we're going to get EBX plus 4. So the offset to the health address is 4. So the base address is 4 less than the addresses we have here. And so we are going to add, we're first going to rename this group to Team 1. We're going to add an address. We're going to add another group, and we're going to call it Team 2. Click inside of that box, and then when we add an extra address, it's going to add player 4. And so player 1's health address is right here. We're going to copy and paste that in, and we want to go to the base address. So health address is 4, C minus 4 is 8, because C in hex is 12. We're going to grab this guy, do the same thing, copy and paste. C turns into an 8. Copy and paste that in here. A 9-4 becomes 9-0. Copy and paste the last one, and then that also becomes a 0. So we are now going to define a new structure, and we're going to call this player. Do we want cheatengine to auto-guess the struct data types? Yes, we do. You can't always rely on it, but it's a good start. The starting size of the struct is 4 kilobytes. That's fine. Just a default setting. And now we see we have Dave, Eric, Hal, and Kit. It properly guessed the string. So name is at offset 15. We can double click it and write name. We have the health variable is at offset 4. So we're going to call that health. And then this is interesting. So the offset 0x0 of every object points to this address, and that's actually a vtable pointer. So we can double click this and just call it a vtable pointer. So health vtable name, and then we see this byte here. Dave and Eric are both on team 1, and Hal and Kit are both on team 2. So we now know that offset 10 is going to be the team number. So what we want to do is make it so that we compare against the offset 10. So to do this, let's right-click player 1's health, find out what writes. We're going to click attack, and that's the instruction, show disassembler. Control A to open our auto assembler. We're going to use our code injection template. Now there's 100 different ways you can do this. This is just what I came up with real quick. So the original code is move EAX into EBX plus 4 and an FLDZ, which I think that pushes 0 onto the floating point stack. Yeah. So now you have both these opcodes in here because when you put a jump here, the jump is 5 bytes. So you have 5 stolen bytes that you need to then make sure that you're executing. If you miss any of those stolen bytes, then there's a possibility that you're going to corrupt the stack or the game's not going to work correctly. So in our new mem, in our injection, we're going to do a comparison on EBX plus 10, which is the team offset, against 1, which is our team. And then we're going to do a jump if not equal, JNE, to original code. So if they're not on our team, we're going to jump to this original code, and we're going to reduce the health. Now, if it is our team, we're going to stay exactly where we are and continue executing. So, important, we want to skip this, but we don't want to skip this, because this could be an important part of the game code. So we're going to redo that stolen byte, FLDZ, and then we're going to jump again, JMP, to original code, plus 5. So the jump is 5 bytes, so we're going to jump back to this original code here, plus 5 bytes, which is going to bring us to this. And so that makes sure that we resume execution after that, and all that we're doing is skipping this. So let's click execute, yes, yes, and now when we hit the enemy, their health reduces. When we attack us, nothing happens. So it worked. Um, let's restart game and autoplay, and that shows that even though the game was restarted, that our injection was still occurring, and now we can click next. Well done, you've completed the tutorial.